Hi guys, I know you're super pumped up to do the completing the square challenge. Alright, I know you guys are like challenge accepted, right? Alright, so it's gonna be exactly what we did in example 6 and 7, except this time some fractions will be involved. But it's okay, because fractions are friends, and fractions just make the problem even more exciting. What I like to say is the harder the problem, the more exciting the problem. Alright, let's get going, you guys. So, remember, when we complete the square, the a and the b need to be on one side of the equation, which I like to put them on the left-hand side, and the c value needs to go to the other side of the equation. So right now, the a and the b, they are not friends with the c, and they need to be separated. They are not getting along right now. Alright, so I need to move my c value to the other side. Do you guys spot the c value? Oh man, it is -6. So I need to move that bad boy to the other side. How do I move a -6 to the other side? Absolutely, you guys. You guys are so smart. All right, so we're going to add 6 on both sides because that's the opposite of a negative. So the -6 plus 6 will cancel and turn to 0, and 0 plus 6 is 6. All right, so we're left with 2x squared plus 5x equals 6. Now remember, you guys, before we can complete the square, so remember the whole point of completing the square is to get this into a pretty perfect square trinomial. So we want something squared. And remember, before we can do that, our a value, do you remember what the a value has to be? It does have to be a 1. Okay, so we want our a value to be a 1, which currently, you guys, is not a 1, it's a 2. Oh no. But it's okay. What can I do to the 2 to force it to be a 1 whether or not it wants to be? We're going to be kind of mean. Oh man, we would divide it by 2, and if I divide one term by 2 to keep my equation balanced, I'm going to divide every single term by 2. Bam, bam, and bam. Alright, which 2 divided by 2 cancels and turns to 1. So this will be 1x squared, or just x squared, plus, does 5 over 2, does that simplify any further? Or can I divide 2 into 5 evenly? Oh no, I can't. But it's okay. We can leave it as a fraction. And like I said earlier, fractions are our friends, so it's going to be great. So I'm going to leave it as 5 halves x. Okay, and it will equal 6 over 2, which is a 3. Alright, so now we're at the phase of the problem where we want this side to become, we're going to transform it into a perfect square, which the way we do that, we have this magical formula we use that will tell us what we can add on both sides of the equation to make that a perfect square. What is the magical formula? It is b over 2 squared. You guys are like mathematical geniuses. I don't even know why I teach you guys. You're so smart. You always know the answer. Okay, so we have b over 2 squared equals, so my b, what is my b value? It is a 5 halves. So this is going to be b over 2 still. It's going to be 5 halves over 2. So it's going to be 5 halves over 2. Whoa. Let's take a look at that real quickly. Oh, man. Take that in. You're probably like, Miss Long, what's going on? This looks really weird and it's irking me. Well, guess what, you guys? It's going to be okay. I'm going to rewrite this in a way that probably will make more sense to you. Okay, so remember, fractions simply just means to divide. Okay, so this is like 5 divided by 2. Okay, so 5 halves over 2 means 5 halves divided by 2. So I'm going to rewrite it with the division symbol. Okay, so this is like 5 over 2 divided by 2. Okay, which since I have one fraction, I'm going to go ahead and change 2 to a fraction, which 2 is secretly over 1. Okay, so I'm going to rewrite it like this, and I bet you guys know how to divide with 2 fractions. How do you divide with 2 fractions? Oh man, you guys are so smart. Yes. Okay, so I have a little catchphrase for this. Okay, what I like to say is keep, change, flip. Okay, so we're going to keep the first fraction how it is. So I'm going to keep it as 5 halves. We're going to change division into multiplication, so that will transform. All right, and then we're going to flip the second fraction. So 2 over 1 will flip into 1/2. Okay, so keep, change, flip. Keep, change, flip. It has a nice rhythm to it, doesn't it? Oh, man. Guys, so now we're going to be multiplying our fractions. And since you guys know how to divide fractions, I think you guys know how to multiply 2 fractions. Guys, so how do you multiply with 2 fractions? Oh, man, you guys are so smart. Holy hot dog. Okay, you do go straight across. So we're just going to multiply straight on across. Alrighty, so 5 times 1 will give me a 5. And 2 times 2 will give me a 4. So this will be 5 over 4 squared. And I bet you remember from the last problem, how do we square a fraction? You do square the numerator and the denominator. So we're going to square the 5 and the 4. So we're going to do 5 squared over 4 squared. Okay, which 5 squared is 25, and 4 squared is 16. And guess what, you guys? We have finally found the b over 2 squared. Whoa, wasn't that cool? Guys, so if you ever have a fraction over another fraction, that's actually called a complex fraction. Sounds pretty cool, right? Okay, you're actually going to learn about that in your next math class, which is pretty exciting. You'll learn more about how to deal with complex fractions. But anyways, when you have a complex fraction, I simply just break it apart into 2 dividing fractions and solve that way. Guys, so this is the magical number that will force this side of our equation to become a perfect square trinomial. But remember, you guys, if we add this on one side of the equation, we got to add it on the other side of the equation. So I'm going to add this bad boy onto both sides of the equation. So we got an x squared plus 5 halves x plus 25 over 16. Bam. Equals 3, so I'm going to bring on down my 3, plus 25 over 16 again. Alright, so we have added it on both sides of the equation. Okay, so after this, it's going to flow very similar to how example 6 and 7 ended up working out. Okay, we just have some fractions to deal with. But again, fractions are our friends, so it's going to be a blast. Alright guys, let's do this thing. Alright, so now that we have the magical number added on both sides of the equation, we're going to rewrite this as a perfect square trinomial, which if you remember, what is the shortcut to write this thing as a perfect square? Holy hot dog, you guys always know the answer. So we're going to square root the first term and the last term. And be careful, we're going to square root that whole fraction, so watch yourself. Okay. So, let's get this thing as a perfect square trinomial. Alright, so the square root of x squared, those will cancel each other out. So we're left with x. And then the square root of 25 over 16, remember, when we square root a fraction, we square root the numerator and the denominator. So, the square root of 25 is 5. And the square root of 16 is 4. And remember, you guys, we take the sign of the middle term, which the middle term is a positive. So I'm going to add those bad boys together. All right, now normally we would add these and bring it down, but we have 2 fractions we're dealing with. So, do you guys know what you must have first before you can add 2 fractions together? Oh man, you do need a common denominator. So 3 is secretly over 1. So I need a common denominator so I can add these bad boys together. Alright, so what is the smallest number that 16 and 1 multiply to equal? Heavenly Hamburger. It is 16. Guys, so since this one is already over 16, I'm just going to bring that one on down. Bring it on down. Bam. Okay, and then I need to transform my denominator into a 16. Okay, so I'm going to multiply 16 to the bottom, but if I do it to the bottom, I got to do it to the top. All right, and this should be added. All right, and like we said before, when we multiply 2 fractions, we just go straight on across. So I'm going to multiply across. All right, so I'm just going to bring everything on down. So we got x plus 5 over 4 squared equals 3 times 16, which is 48, over 1 times 16, which is 16. Do we have a common denominator, you guys? Let's take a closer look. Oh, man, we do. Yay! Party, 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 party. All right, so now that we have a common denominator, I can add my fractions together. So I'm going to bring this on down. X plus 5 over 4 squared equals, so I'm going to leave my common denominator alone. I'm not even going to touch it, so I'm just going to go ahead and bring down my 16. And then I'm going to simply add my two numerators, which 48 plus 25 is going to give me a, let's see here, 73. Bam. All right, and then we just keep on solving. Okay, so the goal, we want to solve for the x, but currently that squared is getting in the way. How do we undo a squared? We square root that thing, and we're going to do it on both sides of our equation. And be careful, you guys. I'm going to square root the entire fraction right here, so be careful. Watch yourself. Okay, so the square root and the square will cancel each other out. So I'm left with x plus 5 over 4. Well, technically, I don't need the parentheses. I mean, it's not wrong, but you don't really need it. Again, those mathematicians just might judge you if you do that, so I wouldn't do that. Okay, so we have x plus 5 over 4 equals. Now, remember, you guys, when we square root a fraction like we did earlier, you square root the top and the bottom. All right, so can I square root of 73? Is that a perfect square? No, it is not. You guys are right. It is not a perfect square. Okay, so what that means is, since it's not a perfect square, what do you have to do to simplify that down? Okay, technically you would do a factor tree, but I'm going to tell you right now, you cannot square root 73. It does not work out. Okay, so that's going to stay as the square root of 73. Over, what's the square root of 16? It is a 4. Okay, and don't forget, you guys, when you square root both sides of the equation, a plus or minus should appear. So I also will need a plus or minus symbol. Okay, you guys, we're really close to being done. We're so close, okay? And I'm going to bring this over here because I'm starting to run out of space. All right, so I'm going to bring this up here so you guys can see what I'm doing a little bit better. Okay, so I'm going to go ahead and separate this into two separate equations, okay? So one time, I'm going to say x plus 5 over 4 equals a positive root 73 over 4. Or I'm going to say x plus 5 over 4 equals a negative square root of 70 over 4. All right, I'm going to zoom back in. Oh, wrong way. Here we go. Okay. All right, so from here, we just need to get x by itself, which currently that positive 5 over 4 is in the way. How do we move a positive 5 over 4 to the other side? We do subtract it on both sides. And I'm just going to go ahead and subtract all of these bad boys by negative 5 over 4. I'm just going to go ahead and knock it out. Okay? Bam, bam, bam. Which these will cancel and turn to 0. Guys, now can I combine root 73 over 4 with 5 over 4? No, I can't, because those are not like terms. Okay, when you have a square root's only like other square roots. Okay, so if this one does not have a square root, you cannot add or subtract it to a fraction that has a square root. Okay, so I'm just going to write them side by side since they cannot be added together. Okay, so I'm going to say x equals negative 5/4 plus, since it's positive, I'm going to write plus root 73 over 4, or x equals, again, negative 5 over 4. This time it's negative, so I'm going to write minus root 73 over 4. Okay, so that's one way you could write your answer. Now, technically, you guys, since these are both over the same fraction, I could just write it as one fraction. They're both over 4. So you could also say x equals negative 5 plus root 73 all over 4. Or x equals negative 5 minus root 73 all over 4. All right? Or another way you guys can write this, if you want to, you could just write this whole answer as one answer with a plus or minus symbol. So watch this. This is pretty cool. All right, so you could also write it as x equals negative 5 plus or minus root 73 all over 4. So guess what, you guys? Any of these options right here are acceptable answers. So you can write your answer as any of those. Isn't that cool? I mean, one answer is already pretty exciting, but having 3 different ways to write the same answer is like a whole nother level of exciting. I mean, I'm pretty flipping exciting right now, so that's awesome. All right, well, guess what, you guys? We have completed the Complete the Square challenge. Wasn't that cool? Look at that lovely work. I just love to marvel at my work when I get done. Oh, man, you guys, that was awesome. Way to go. Nice job.